How big is our universe? In all of its vastness, our universe might seem to be infinitely large, but this world is in fact bounded by a few physical limits. Information. Without getting into the quantum woo-woo of spooky action at a distance, the ultimate rate at which information can propagate is bounded by the celerity of light. In practice, what this means is that light defines the maximum speed at which anything in our universe can travel. Distance. Distance is measured by the amount of time it takes light to travel between 2 points. We may choose to express that measurement in meters, miles, or bees, but ultimately that unit will be tied to the speed of light. If we pair this with the fact that our universe is estimated to be around 13.8 billion years old, then we can calculate that the furthest distance anything could have travelled since the beginning of time is 131 sextillion kilometers. To put this into numbers that we might somewhat be more familiar with, what this means is that the furthest away any observable event can exist in relation to us is 13.8 billion light years. Oh, yeah, well I guess that makes sense. But it doesn't stop there. Since the beginning of time, our universe has also been continually expanding, meaning that the actual figure for the size of our universe should be a bit bigger. In the 1920s, astronomer Edwin Hubble estimated this expansion rate to be at around 70 kilometers per second per megaparsec, meaning that for every megaparsec of distance, our universe should appear to be expanding at an additional rate of 70 kilometers per second. Theoretically, with this recessional velocity, also known as Hubble's constant, we should now be able to calculate the size of our universe. However, just in case this wasn't already complicated enough, the expansion rate of our universe has actually been evolving over time. For example, the expansion rate of the early universe was a lot faster than it is today, and so we also need to take into account this variation of Hubble's constant over time in order to get a better estimate for the current size of our universe. So, if we take into account the current age of our universe, its varying expansion rate over time, as well as the celerity of light, then the revised figure that we get for the size of our universe is 46.5 billion light years. This is how big our universe is today, but it just keeps getting bigger. Ultimately, our universe will continue to expand until its inevitable heat death, a moment in time far, far out into the future. And this covers the question of,